Hello, it's Keith here, and this is lesson 32 of the simple series of my 650 assembly programming tutorials, and we're doing sprite clipping or sprite clipping of sorts today. This is probably the last of the clipping tutorials. I say of sorts because we're really doing a character graphic on the pet. It's not quite a sprite as such, but we've got our little animated man here. We looked at this before, we had the simple series before with this little animated character and would move around the screen, but now it can partially go off the screen. So we've got some simple clipping in place here. So this is a basic example of how even on a system that only has the character block graphics, we can have an object we move around and we can clip parts of it to allow it to go on and off the screen. Now, as usual with my tutorials, the graphics were created with Sprite editor. Here are the frames of animation. So these were all exported with the export option up here. If we go to pet here, it was this save raw bitmap full scale option that I used here to export this character into raw binary data for our code today. Now the code today will handle the clipping, and just before we do that, we're going to discuss the concepts behind the clipping code. So the first thing I'm going to have to discuss is the logical units. Now, the tutorials that I do here and all of the code, which is multi-platform, is designed for systems with a 256 by 192 pixel screen. Now, that's not quite true of the PET because the PET doesn't really have bitmap pixels, but we have to work in a common way in all systems. The other thing we have to do is we have to work within 1 byte values for our x and y coordinate, and so what I want to do is I want to have a visible screen in the middle of the screen, and I want to have an invisible area around that, and it all has to fit from 0 to 255. So what I typically do is work in pairs of pixels. So our 256 by 192 screen becomes a 128 by 96 logical unit screen, and we have a minimum value of something like 64,80, which is the first visible pixel, and 192 by 176 is the last visible pixel, and everything else is outside of the screen. So if we draw Chibico here, only this corner here will actually be visible and the rest will be cropped off. Now on this system, on the PET, we're working in character blocks, and so each character block is 4 by 4 logical units, and we're not going to be able to move with any more definition than that because our code is not smart enough to do that. So that is one limitation we're going to have, and that's how the logical units work on this system. Now the other thing we're going to have to discuss is the concept of our cropping routine. Okay, so let's just quickly go over how the cropping theory is going to work for the code we're looking at today. So here is our screen. That's the screen of our visible game area, and then we're going to have our little character here. There's our amazing graphic that we're going to be drawing here, and that's going to be in some kind of box, and then as our character moves around the screen, we're going to show it to the screen, but if it goes off the screen, we're going to have to remove part of it. And so if it goes off the top of the screen, what we're going to do is we're going to skip this part of the character data. The character blocks are converted to bytes. It's 4 by 4 character blocks, so 16 bytes total. So we need to remove this part, and we need to change the height to this part here if it goes over the top. If it goes over the left hand side though, we're going to have to do things differently. We're going to have to skip this part, we're going to have to change the width, and then after each line, before we draw the next line, we're going to have to skip this part. That's if it goes over the left, but if it goes over the right, we're going to have to change the width to this part, and after every line, we're going to have to skip this bit, but we need to skip nothing at the start of the sprite. Of course, if it goes over the bottom of the screen, well, we don't need to actually skip anything, but we do need to change the height. Of course, there is the possibility it will go over multiple sides of the screen, in which case we're going to have to do various combinations of those tasks. So that's the challenge we've got ahead of us, and that is what our code is going to do. Okay, so here's the code that we've got today. So we're defining the logical screen size and minimum coordinates. There's the minimum coordinates, there's the width and height. Now this is a 320 by 200 screen we're defining today. Of course that is pixels, but we're working in character blocks. And we've got some temporary registers here, 0 page entry, sorry. They're simulating the Z80 registers because this was ported from the Z80. Now we're not going to go over the code that handles the reading of the cursors and the moving around of the object because that is almost identical to the simple series. We're just going to look at the graphic routine changes here. So we're going to look at the draw player code here. Now first of all, we're calculating the offset within the bitmap data here of the character we want to show based on the frame of animation and also the direction. That was the same in the previous example, so we're not going to cover that in any more detail. First thing we're going to look at here is this part here. Now here we're loading the width and the height in logical units. Now our character is 4 by 4 character blocks, but there are 4 logical units per character block, so our logical unit size is 16,16. We are then running this do crop routine, which is going to calculate any required cropping, and it's also going to change the offset for the sprite as required. We're going to look at that in just a moment. And it's going to set the carry flag if actually our sprite is entirely off the screen and there's nothing left to draw. So we're going to have a look at that now, and we'll come back later and have a look at the actual sprite drawing routine that's getting the graphic data onto the screen. Now, the first thing to notice here is that at the start we've got this all off-screen routine which will set the carry in return. We're going to call this various times when our sprite is completely off the screen and we're having to give up. At the start of our cropping routine here, we're loading y with 0. Y stays 0 throughout this code, so sometimes we'll store y to quickly set something to 0. And we're setting sprite hclip here. That's the amount of sprites or blocks to remove when our character is partially off the left or the right of the screen after each line has been drawn, because either case we will need to remove a few blocks. And we're then defining d and e as 0. These are just two temporary variables that we use as part of our calculations. So the first thing we're doing here is we're loading the y position into the accumulator here, and then we're subtracting the minimum y, and we're effectively moving our sprite up the screen, up the values here, and if we are partially off the screen, this is going to go into a negative value. And if that is not the case, then we don't need to crop the top, but if it is the case, we're converting that negative value to a positive, and then we're rounding up by 1, and we're converting that to a number of character blocks, because remember, 4 logical units per character block. We can only crop in character blocks in this code. We're then comparing the number of character blocks we need to remove to the height of the sprite, because if it's the entire sprite, we're entirely off the screen and we want to give up. But if it's not, we're going to store that in E, and we're going to use that for later. We're then going to 0 our Y position because we're drawing from the top of the screen. Okay, so that's handling the sprite at the top of the screen. Well, what if our sprite's at the bottom of the screen? Well, we're going to deal with that right now. So now we're adding the height of the sprite here. We're then subtracting the height of the screen here, and then we are seeing if that has caused an overflow, and if it hasn't, then there's nothing to crop. Otherwise, we have got to crop the bottom of the sprite. So we're again converting to a number of tiles here, comparing to the height of the sprite, and if my number to crop is the same or greater than the height of the sprite, then we need to give up. We've got nothing left on the screen. Otherwise, we're storing that into the amount to remove from the bottom. So D is the amount to remove from the bottom, E is the amount to remove from the top. And now we're going to use those to crop our sprite vertically. So we're loading the amount to remove from the top, adding the amount to remove from the bottom, and if it's not 0, we're then converting that to a negative value and adding it to the height and storing the new height. We've now converted the height to the correct height, but we need to remove any object items from the top of the sprite, because if our sprite is at the bottom of the screen, we still need to draw the first parts, but if it's off the top, we need to start from somewhere in the middle of the sprite, and that's what we're going to calculate now. So what we're doing here is we're loading in E here, the amount to remove from the top, and we're converting that to a number of tiles, a number of characters, so we're shifting to the right twice, dividing effectively by 4, and storing that in X. We're then calculating the number of bytes, and we're then taking the width of our sprite here, and we're converting that into a number of bytes per line and storing that in E. And what we're basically going to do is we're going to do a crude multiplication here, and we're going to add E times X to the starting character block position within our bitmap. That is the data that was exported from our sprite editor that makes up our moving character. So IY is our source data here, and we're repeatedly adding E until X becomes 0. That is effectively skipping the first part of our character if our character is off the top of the screen like that. Okay, so we've cropped the top now and the bottom, and we're now going to do the left and the right. So we're zeroing D and E again. We don't need the old values. We're now going to use those for the left and the right. So we're then loading in the X position. We're subtracting the minimum X visible logical unit again. And if that has not caused an overflow, then we're not needing to crop the left-hand side. But if it has, then again, our sprite must be partially off the left-hand side like that. So we are negating that, and then we're comparing to the width to see if the entire sprite is off the screen. And if it is, then we're entirely off the screen, and we need to jump to the all off screen and give up. Otherwise, we need to convert this to a number of tiles. So we're rounding up here by adding 3 here, because there's 4 logical units per tile here. And we're storing that in ZE here. That's the amount to remove from the left-hand side. And we are setting the X position to 0 here. That says draw from the top. That's wrong. That should be draw from the left, because there's a mistake in my documentation there. It's not very good. Anyway, that's cropping the left-hand side of the sprite. We're now going to do the right-hand side. So what we're doing here is we're adding the width of the sprite here, and we're comparing to the width of the screen in logical units. If there's no overflow, then we don't need to crop the right-hand side, so we're just going to skip. But otherwise, we are comparing to the width of our sprite, because clearly part of our sprite is off the right-hand side. So we need to work out if that's the entire sprite, and if it is, again, we return. Otherwise, we store the amount to remove from the right in D. Now what we're doing is we're adding the two parts together. We're converting them to a number of characters, and if that is 0, then we're going to give up. Otherwise, we store the amount we need to remove in spriteh clip, which is the amount we take off after each line. We're then converting this back to logical units for a moment, and we are negating this and adding it to the width, and we've now updated the width of our sprite here. We store the new width here. Now what we're going to do is we're going to load the amount we want to remove from the left, and we're basically taking off the first few character blocks if our character is at the far left, because we want to start from somewhere other than the first character in that case. So we're loading E here, and we're then converting that to a number of character blocks, adding it to IY and updating IYH if required, and then we're done. Now the final thing we're doing here is we're converting all of our coordinates from logical units into character blocks. Effectively, we're dividing them all by 4, and that will convert them into units that we can use in our code as part of our sprite drawing. So now we've got values in numbers of characters and an X and Y position in characters. We're going to use this function gitvdpscreenpos to calculate our VRAM destination here. Here it is. Our formula is pretty straightforward. It's basically the memory base for the screen memory, which is hexadecimal 8000. Our Y position is 40, and our X position, each character block is 1 X position. Now, we want to multiply our Y position and character blocks by 40. It's pretty hard to multiply by 40, so we multiply by 32 with bit shifts, and then 8 by bit shifts, and we add the two together, and that's what we're doing here. So we're loading our Y position here, and we're effectively multiplying it by 8 and then by 32, and we're adding those two together there. And that's the same as in the simple series. Now, once we've done that, what we're doing is we're loading our width into the X register here, and we're using Y as basically an offset, and we're loading bytes from our source in IY and storing them to our destination VRAM in DE, repeatedly incrementing Y each time and decrementing X, which is our counter. Once our counter reaches 0, then we've done our entire line. What we then want to do is we want to move down our destination memory address by 1 line, which we do by adding 40 to our DE pair here. That's what we're doing there. But there is something else we need to do. We need to skip any horizontal bytes. If our sprite is either on the left hand or the right hand, either way, we're going to need to skip a few blocks before we start drawing again. And that's what this spriteh clip does. So we're adding that to the IY pair. And then the other thing we're doing is we were using Y as an offset here, but we also need to add Y to our IY pair, and that's what we're doing here. Once we've done that, we're decreasing ZL, and once that reaches 0, we're finished. Otherwise, we're jumping back to the top here, and we're showing the next line of our character block. And that's how we're getting our little character to the screen. And that's how we've got our example here. So, I mean, the hope of this is that maybe it's a nice little simple example for you to get started with. And as I say, you can export the graphics in the raw format that this tutorial uses and the PET screen uses with the Sprite editor, which is of course free and available on my website. As I always say, go to my website, download the source codes of build scripts and also Sprite editor. They're all free and open source, and you're welcome to use them in any way you want. Even if you somehow manage to make an amazing commercial game with it, well done to you. I'm kind of doubtful you can, but good luck to it, because there are only simple examples on there. Anyway, if you've liked what you've seen, please like and subscribe. If you like the videos, YouTube recommends them to more people and I get happy. And if you subscribe, you'll see all of the amazing content I've got coming up in the future, or at least all of the vaguely passable content I've got coming up in the future, which is possibly more technically accurate. Anyway, whatever you do, I hope you've enjoyed it. Thanks for watching, and goodbye.